Hello all. We have been discussing about different types of grounding in electrical measurements. We had already discussed about what grounding is and what is the purpose of using grounding in electrical measurement equipments. So today we'll be discussing about there are different types of grounding actually. First one is earthing or normal grounding. Second one is equipment grounding. There are other types of grounding called isolation grounding, standard grounding, etc. We'll discuss briefly about equipment grounding, and the rest of the types of grounding I'll send you in notes. Now, equipment grounding refers to the connection to power system ground of all non-current carrying metallic parts of a power system that may come into accidental contact with circuit phase and neutral conductors. Now, these metallic parts may include raceways, conduits, equipment grounding conductors, equipment enclosures and racks. All these items are ultimately grounded together at the grounding electrode of the power service or a separately derived system. Now, this is required for both personal safety and power systems protection. From a personal safety point of view, properly grounded system components minimize potential differences that may exist between various system components under transient and fault conditions. Now, from a system protection standpoint, properly grounded system components provide a low impedance path for ground fault currents and promote the timely operation of overcurrent protective devices in case of ground faults. There are two different grounding configurations associated with connections of the equipment to the PE point: the standard ground configuration and insulated ground configuration. For the standard equipment grounding configuration, a supplementary ground conductor provides an additional low impedance ground path in parallel with the metallic conduit or raceway from the equipment to the power system. In case of isolated grounded configuration, the electronic or electrical load is not connected to the metallic enclosure, and this metallic enclosure is earthed through an independent conductor to the start point of the safety ground. The insulated equipment grounding conductors run with other circuit conductors feeding electronic load equipment. In an isolated ground configuration, the additional equipment grounding conductor provides the sole grounding path from the electronic or electrical load equipment to the power system or separate derived system. I will go into multi-point and single-point grounding connections. So, depending on the connection of different components of the system or units into a single signal reference system, depending on how they are actually connected, there exist different types of grounding configurations. Now, these are multi-point grounding configurations and single-point grounding connections. The determination to use single-point grounding or multi-point grounding depends on the actual frequency range of interest. Now, with analog circuits that have signal frequencies up to 300 kHz, we can use single point grounding configuration, and for analog or digital circuits with signal frequencies in the megahertz range, that is higher frequency operating range, we should be using multi-point grounding systems. Now, single point grounding is usually implemented with a physical bus where all the conductors are connected prior to entering or leaving the signal reference grid area. This configuration would provide a well-defined and concentrated current path through the electronic load equipment, which could cause performance problems or component damage. Now, this is the easiest configuration of grounding and is very useful in case of small systems. But if the real configuration of a single point grounding system is examined, you can see that this is largely undesirable from the EMC point of view. EMC is electromagnetic compatibility. First, because of the big inductance that the ground path presents, and second, because of the large amount of wire that becomes necessary in the case of single point grounding systems. Now, this is a diagram for single point grounding configuration. Shows that there are different units and all are connected together to a single ground point, which is connected to the ground directly. You can see that there are large amount of wires required from different units which are to be connected to the grounding point. The actual single point ground configuration is shown in this figure. This is shown in a little more detailed form. You can see this diagram in detail. Now, multi-point configuration. In case of signal reference systems, we generally do not use single point grounding. In this case, we use multi-point grounding systems. So it requires that all the metallic objects crossing or intersecting the signal reference system are effectively bonded to it. Now this kind of grounding configuration minimizes the possibility for all types of electrical currents flowing in the signal reference grid to be unwanted onto a few conductors of signal reference system. Based on this type of grounding, it's strongly recommended to separate at the origin the ground of analog signals, digital signals, power supplies and racks, and afterwards connect them in a specific way that minimizes the differential of potential between different grounds. You can see how a multi-point ground configuration is done using this figure. Now this is all about single point and multi-point ground configurations. Now we'll see about shielding in the next lecture. Thank you.